I did the 675 first.
Yes, that is correct. So we're on the random problems for mortgages, reviewing what we did last class. So the 15-year loan and 7% told us that $8.99 would get her $1,000 of mortgage. So imagine that she shows up at the bank with a suitcase with $676 of cash in it. And she says, here's $8.99. And the bank says, great, have $1,000 of mortgage. And then she says, here's another $8.99. And the bank says, now you're up to $2,000 of mortgage, and so on. And they keep doing that until she runs out of money in her suitcase. So how many times does $8.99 fit into 676? That's what division does. So 676 divided by 899, and I get about 75. So that 75 is counting thousands of dollars of mortgage. Oops, not the. So she needs to start just by looking on around, find a $75,000 house. Everyone okay with step one?
Yes.
Yes, I see a thumbs up. Okay, thumbs up are good. They let me know I can keep going. So eventually, she does some house shopping. She finds a home worth that much. It has a 23% down payment. So we just found it was 75,000. So we're asking, what is 23% of 75,000? We'll talk about this later because we'll move to saving for retirement probably before the end of the class. And these types of percent sentences we'll use again and again. There's two ways to do this, a translate method and a proportion method. I'm going to start with the translate method. In any word problem, what becomes the letter I'm solving for? Is becomes equals. If I want to take a percent and put it in my calculator, then we had that right into percent, left out of percent, rip lop. We're going left out of percent in this case. Of becomes multiply, and 75,000, the number just stays a number. Is there anyone that needs more review of just that foundational step of taking a sentence with words what is and of, and translating it into an equation with y and equals and times? Actually, I'm going to change that to that kind of times. I can do more of those if we want. I will do more anyway, but if it's something you need right now, let me know. Okay. So what is that? I take my 75,000 times 0.23, so 17,250. Questions on either number one or number two? Okay, so we keep moving. The loan has a 1% fee. What is the fee amount? Let me make sure that I am, doing that. It's been so long since I programmed my answers. I wanted to make sure I wasn't messing it up. Okay, what I can't ask, so don't write this. I'm writing the wrong thing now. What it sounds like I might want to say is, what is 1% of the 75,000? But that's wrong. So somebody tell me why that's the wrong question.
Because you,
I did.
there,
I'll give you a hint. It ties back to this problem.
yeah, because we don't have the actual loan amount fully, do we?
Right. She doesn't owe a fee on the down payment. The down payment amount she just pays cash up front. That's not actually part of the loan. So we need to find what the actual loan size is. So there will be a number that goes in that spot, but it's going to be smaller than 75,000. So we're going to take away the 17,250. So 57,750. Okay, give me a thumbs up in Moodle or say something in chat or something. Some of you have been too quiet for several slides. Yeah, good, good. Okay, so that's how much she actually owes the money on. Now it's the same as we just did before. What becomes y is becomes equals. We take our percent and we replop it. Of becomes multiply. A number stays a number. 0.01 times something is just going to be 2 decimal point scoots this way. So we're getting $5,775. So when you're doing these in homework, when you're doing these on the test, because again, the random problems become the test problems, don't get tricked. It didn't actually say what's the actual mortgage. Pay attention. You need to find that even though it doesn't ask you for it. Okay, number 4. how much will she actually pay over the 15 years? I need several pieces of old information. What do I need from this slide?
Need the 75.
I don't actually need the 75. We're done with that because as soon as we found the actual loan size, then we're done with the 75. That was just her ballpark to do her window shopping of houses. So from this slide, what I need is the table that tells you how much she's going to pay things. From the second slide, I don't need that. Her monthly payment isn't based on the down payment. On the third slide, I need something. I need her actual loan size again, because that's what determines her payments. So when you are doing your random problems and get to number 4, then jump back and say, I need to know first the payment for 15 years, 7%, and second, how big a loan she actually bought. Then I can put those together. I want to know how many thousands this is, because we're paying per 1,000. So it's not 57,000. That would round it. What do I do with the 750?
Do we just do 57,000?
No, that would leave out the 750 from
We
her.
can't do that. Yeah.
So
Wouldn't it be about 58,000?
we could round up to 58, but the bank is not going to round at this point. I'll give you a hint. Okay, now I'll just answer it. So I'm going to do 3 decimal point scoots to say it's 57.75 thousands. If we're counting by 1,000, how many times do we have to count? 1,000, 2,000, 3,000, 4,000. We'd count 57 times, and then we'd do 0.75 more of accounting to almost get us up to 58,000, but not quite. This is very different than the ripple-up. The ripple-up happened because we took a % sign and got rid of it. And we had to put in something that means the same thing. And dividing by 100 is the same as a per 100. This is different. That this number is about how many times you have 1,000. So how many times do I have 1,000? I have 57 times, and then a little bit of a decimal. So we're dividing by 1,000 instead of 100 because the table cares about $1,000 of loan. This is for most students the trickiest part. So after we finish this set, I'm going to redo a number 4 with a different random number. Okay, anyway, for each of those, she has to pay $8.99. Because I'm in a math class, rounding this to 17 cents. On the calculator, it says $519.1725. And it's probably true in real life that the bank would round this up to 18 cents. So they're not losing a little bit of money over 15 years. And I think there was an old Eddie Murphy comedy about how this extra fraction of a cent adds up, and somebody played by Eddie Murphy was some con man that figured out how to steal the money. Does that ring any bells to people? Anyway, I'm too old. So if you wanted to round this up, you could, but I'm just going to follow the normal math rules. Okay, so once again, as we mentioned last time, she budgeted 676. Because we took off a big chunk for the down payment, her monthly payment is actually a lot less than that. But we're assuming that that's realistic, that she doesn't just get the down payment for free out of thin air. She's borrowing it from family or friends or something. And so she has to be, in a sense, paying this back also, just not to the bank. So it is good that what she is paying to the bank is less because she has some other obligations she's dealing with. Okay, we're almost done.
David, I have a question on that one.
Sure.
So I was thinking to get the monthly, after taking all those steps, to get the monthly payment amount that I would have took the rate, the $8.99 times the loan amount.
We did multiply them together.
Basically, we just, okay, and that is what we correct.
Your audio is cutting out. I can't quite hear what you're asking. Try again, please.
So I was just verifying that we do take that rate and we times it by the loan amount, the monthly.
But the loan amount, we're just counting how many thousands are in that loan amount. So we had to do the 3 points of decimal scoop first, because this is per thousand, not per $1 of loan.
Okay, thank you.
I'm not sure why. It's not like it had to be that way. You could have a different amortization table where all of these numbers were tiny decimals because all of them had been scooted so that it was how much you owed per $1 of loan. But that's not how whoever invented this table actually did it. Since they made the table per thousand of loan, we have to translate in red and say, well, how many thousands are actually in this loan amount? Okay, she's going to pay for 15 years, the $519.17. So I'll take that amount. How much does she pay in 1 year? How many payments will she make?
12.
12. And then we're not done because she has 15 years. So whatever that is, so that's how much she pays total. Now that's not what the question asks. The question asks how much of it is interest. So who remembers from last class how to get to the interest amount?
total minus the loan.
Yeah. The loan was 57,750. Anything that's not loan has to be interest. So, 13. There we go. Is it too early in the morning for my math? Yes, it was too early. That should be 35. Okay. In the example we did last class, the interest on a 30-year loan was more than the loan amount. This time it's a 15-year loan and the interest is less than the loan amount. So those are both normal behaviors. That's why you pay a 15-year loan if you can, because then you don't pay as much interest overall. But the shorter the loan, the bigger the numbers get on the table. For a 30-year loan, she would only have to pay $665 as her factor instead of $899. It also kind of depends on people's career plans. If you're thinking that, well, in 20 years from now, I'll have a much better job and income, then sure, I'll have a 30-year loan because a bunch of that money will kind of be easy money by the time my career is established. Whereas if you think your career isn't going to advance as much, then you might as well get the shorter loan and have less interest because it's all going to be sort of equally difficult money. Okay, I want to do another random one, but first, any other questions about the set we've done so far? Okay, let's generate a new random one. Again, I'm most interested in number 4 because those 3 decimal point scoots tends to be the biggest place people mess up on the test. It's too similar to percent scoots, even though it's for a totally different reason. But I can't just start at number 4. I have to do the work beforehand. Okay, so here we have a 20-year loan. 7% again. So this time our number is $7.75. The first problem we were just dividing. Comes to the bank with $1,000.92 in the suitcase. He hands it to the bank teller, $7.75 at a time. And they can do that game about 141 times before they run out of money. His down payment will mess this up, but in general, we know that Archibald is looking for about $141,000 of home size. "24% of something." We had that translate game. If you've done this a lot, then you know you're just going to multiply 0.24 times that dollar amount. But if you haven't done it enough to know it's just going to turn out to be multiplying, that's fine. Do the translate. So by the way, when we get that far, if we take away the down payment, we get the actual loan size. Okay, questions with this slide, the first two problems? I'm going quicker because we just did one. Tell me if I'm going too fast. Okay. For his fee, we're going to take that actual loan size, 107,160. Is it okay if I do the shortcut, just times 0.02? Last time I translated it, but I think you're seeing the pattern by now. Is it okay that I skipped the translating step? Anyone want me to go back and write it? We're okay. Okay. So how much will be paid over the 20 years? Actually, I don't want to put them together. Let me get those separate. Because this one I did want to focus on. Okay, so I'm going to take that same 775 and do something with it. I'm not going to multiply it by 1,007,160 as a plain number. What am I going to multiply it by instead? That looks very similar.
Is this where we're going to move our decimal 3?
It is. Actually, look at's not quite the right word. Let's say counting by thousands. I'm counting by thousands. How many times do I count to get to that number? I count 107 times and a little bit more of a time. Now that would be 1 month. So far, if we actually did that multiplying, which we could, that's our monthly payment. So we also need the times 12 months per year and the times 20 years. We did this in more than one step a moment ago. So let me go back and show you. Keep it clear in your brain, and then I'll come back to this slide. Before, we found first her monthly payment, taking that scooted number and multiplying it by the table value. And then we multiplied it by 12 and 15 as a second step. Now I'm doing it all at once because I expect this is what you'll actually do as you're practicing homework. We can take the monthly amount and know that she'll pay that each month. And then we need to multiply by 12 and 20. Everyone okay with that? That's sort of the complicated thing.
Yes.
Okay, then finishing up is just subtraction. If it's not part of the loan amount, it has to be interest. And I'm not going to try and do subtraction by hand because I have shown that I didn't get enough sleep last night for that. I don't think we've done a 20-year loan problem before. So how does the interest amount compare to the loan amount for 20 years? Here's our interest. Here's the loan size. They're not the same. The interest is smaller, but pretty close. So 30-year loans, the interest is much bigger. 15-year loans, the interest is much smaller. 20-year loans, it's fairly close. And I realized that I had written my box around the wrong thing. So let me fix that. I got confused and I boxed this number. That's the monthly payment, but that's not what it asked. So I shouldn't have put my box around it. What I should have actually boxed was this amount. Oops. What problem 4 asked was how much total she paid. So there we go. What did she pay total? That's the amount I should have boxed. Okay, did it better this time. We could certainly do another one, or have we seen 2 and now we're bored of this and want to go on.
Can we do one with annual income?
Can we do the one with annual income? Which one is that? From the turn-in homework?
Yes.
Okay, let's do a turn-in homework. So number 4 you're talking about?
Yes.
So we're starting a little bit before where we started in the random ones. The random ones that will show up on tests, we were just told they can afford this much per month. Here we're looking at he has an annual income of this amount, and he's going to spend 30% on his mortgage. So we need to know what is 30% of 65,000. I'm going to translate because I expect that will help someone, maybe someone at home watching this instead of someone who's been watching it live, but still. Now this number is going to seem suspiciously big. I need to label this carefully. He's not going to write a monthly mortgage check for $19,000. So what step am I missing? let me re-ask that. This number is way too big to be a monthly mortgage check. So,
We gotta do the 3 scoot.
no, the 3 scoot is to say I am looking at an actual mortgage amount, a loan size, and I'm changing it to be how many times I'm counting by thousands. So that's not what we're doing here. This isn't a loan size. This is what he wants to spend on his mortgage, but it's not per month.
Which one were you switching on the last slide?
The last one,
Yes.
that we had to do a 3 decimal point scoot here because we're saying that this was the loan size, but the table value from that table deals with per thousand. So we had to say how many times we're counting by thousands to get to this. So we
Okay.
count 107,000, and then it turns out to be 0.16 to get to the 160.
Okay, thank you.
So that's not our answer yet. We'll deal with that eventually if we follow Zane's problem on the turn-in homework. But for now, there's just something wrong that this isn't his monthly mortgage payment.
Do we have to do something? Oh,
We have to do one more step.
is it divided by 12?
Yes, perfect. Thank you, Donna. This is his annual income. So this is his annual mortgage amount. This is what he wants to spend on his mortgage per year. So we need to do a divided by 12. So he wants to spend 1,625. Now that Donna solved the puzzle, can everyone else see why that was necessary? Oops, but I shouldn't put a box on it because I'm not done. So this is how much he wants to spend per month. Now we're to the part where the other problem started. We know how much they want to spend per month. So we need to take the table. Oops, take the table. And say, what's up with this problem? We have 15-year loan. We have 5%. So we're going to do 791. Do our divided by. This is him showing up at the bank with the suitcase full of money thing. And we get about 205. So that's counting by thousands. His loan size will be about 205,000 before the down payment. And if we were to go back to the turn-in homework and follow this along, then we'll do the other things. But this is what made it different than the previous example problems. And again, the big tricky
But
thing
could you
is
move
this
your
divided by 12. Go on.
Could you move the screen up just a little bit so we can see the lower?
No, I can't move it up.
I can see the lower
Alright.
part.
I can, let's see. I can take the bottom part and put it on a new slide. Is that what you wanted?
Yes, thank you.
Okay, any questions about mortgages before we're done with that? We've done lots of random problems. We've done the difficult part here. This one, it asks you to try doubling one number and then following through, or try having one number and following through. See how things actually work. I think you're quite ready for the homework. Okay. Ask me questions. Saving for retirement starts with a review of Math 20% sentences. And I'd like this to be kind of all we do today. If you don't ask me any questions, we'll go too far and actually get into the stuff about saving. But percent sentences are probably worth reviewing for 20 minutes. So here we go. So a percent sentence is our jargon. It's not necessarily percent sentence is a phrase that will show up in a different book or when you search Google or something. But this is what we're calling a short word problem that has the words is, of, what, and percent. So these are percent sentences. What is 35% of 60? 12 is what percent of 5? 5 is 2% of what? Things like that. There are two different ways to solve them. The translate method, we already did a bunch today. Of means multiply, is means equals, what means y. When you get to the percent, use riplop. There's also a proportion method that if you were in my Math 20 class, I know you've seen, unless you were absent that day. But if you haven't seen this, then some people like that a lot, so we should show you this method also. So let's take these three problems and do them both ways. So the translate method was what we did. We're going to say what and is and percent and of and the number. What becomes y, is becomes equals. We riplop our percents. So far, so good. That's like the ones we just did. What if things are in a different order? It gets a little bit trickier. Not much, but slightly. So I wrote too many arrows. 12 I will change into 12. Is, I will change into equals. What becomes y? Percent doesn't become anything. So I'm going to erase this arrow, but I sort of am owing some work somewhere. We'll see what happens. Of becomes times, and numbers stay numbers. So 12 equals y times 5. How do I get rid of a times 5 on both sides? I'm sorry, how do I get rid of times 5 attached to y? The opposite of times 5 is divided by 5. And if I do it to one side, I have to be fair and do it on the other. So 12 divided by 5 gives me 2.4. Okay, my answer is 2.4, but I'm not done. Who can tell me what I need to do?
Um,
You got to make it a percent.
I got to make a percent. It asks for a percent, and this number is a good number. There's nothing wrong with 2.4, but it's not a percent. It's not in percent format. So I'm going to use my riplop. Go right into percent. And y is 240. Can you see the bottom of the screen okay this time?
Now,
So again, what happened was I maybe could have translated percent, but I don't. When I took that away, I just had to remember that it's going to ask me for a percent, so I'm going to have to fidget at the end and make it the percent. Whoops, I wrote it wrong. 240%. There we go. Now I finished. And let's do another one. Okay. So 5 stays a number, is becomes equals. When I have a percent, I do my riplop. Of becomes multiply, what becomes y. How do I solve 5 equals 0.02 times y?
Cross multiplication.
That's for proportions. I don't have proportions here.
so y would equal 5 times 0.02.
Not quite. I have a times 0.02 stuck onto y. So what's the opposite of that?
Divide.
Divided by 0.02. So then y is by itself. 5 divided by 0.02 gives me 250. And I'm done. It doesn't ask me for a percent. I don't have to fidget with it like last time. I just have my answer. Okay, so in these 3 cases, there's some similarities. If something is stuck onto y with multiplying, then we have to divide. If something is stuck onto y with multiplying, we have to divide. Since the percent sentences have of, that always makes multiplying. So in theory, don't write this, I could have a very different kind of algebraic thing that says 6 or y divided by 6 equals 2, and I would multiply both sides by 6 and get y is 12 and so on. But we won't ever see this, since nothing in the the words ever turns into a divide, then that's not something we will see in Math 25. We always have the word of, which will always change to multiply. So we'll always have multiplies, and that means that the step to solve it is always divide. Did I say that okay? So the fact that we're dividing by something is just kind of par for the course. That's what we do. Every now and then we'll luck out and the y will be by itself, and then it's easy. But 2/3 of the time, there will be something stuck onto y with multiply, and then we have to divide both sides by whatever is stuck onto y. So this is the translation method. Some people love this. If you do, great. If you don't, let's talk about the proportion method. So the proportion method has 4 steps that if I were to try to read them out loud to you would confuse you. So I'm just going to do it and you can see it that way. Whoops, that's not what I want. So step 1 for the proportion method, same problem as before. We know the answer will be 21. Step 1 is to write fraction bar equals fraction bar. Kind of the skeleton of our proportion. Step 2 is we'll take the right ratio and make it represent the percent. It's some number over 100. So 35% will be 35 over 100. Notice in this method, there's no rip-flop. Because we are using over 100 to represent a percent, we don't have to do anything else to represent percent. Then we have something over here. This value is what follows the word of. There's always going to have to be something after the word of. I can't make a good English sentence that ends in of. So in this case, of 60, the 60 goes there. And then lastly, something is left over. In this case, it's the word what. So the what goes there. Let's set up the next one for a comparison before we actually finish the one we did. We do need to finish this and get to 21, but let's do this one also. So first step, fraction bar equals fraction bar. Second step, find the percent. Well, we don't know the percent this time, so let's write it as something we don't know over 100. Third step, of something. In this case, the number after of is 5. Fourth step, what did I not use yet? The 12. Any questions just on the setup of this proportion method before we finish by cross multiplying and solve these? Donna is good. I see a thumbs up. Okay. So this process is a little awkward. It's kind of like learning to ride a bike, but once you get used to it, it goes very fast. And then once you have this, the cross multiplying often makes people happy. Some people just want to cross multiply as much as possible in a math class, And this is your chance, instead of translating things, to cross multiply. Something is stuck onto y with times 100, so I will do divided by 100 to both sides, and we get y equals 21. What makes this especially popular as a method is, remember, if you are done with math at Math 25, if you're not going on, then we have that shortcut where we take the two things that are numbers opposite each other and we multiply those, and then we take the odd one out opposite the y and divide by that. When I do 12 times 100 divided by 5, I get 240, and I just put the percent sign on. There's no riplop in this method. No riplop. We have the over 100 that already does the equivalent. Okay, I still need to do the third one with proportion method questions before I move on to that. You don't need to learn both methods. Pick whichever method you like best. Okay, look at your notes. What's my first step?
Equals and 2 bars.
Yeah, write it out.
Writing it.
Okay, second step.
I would take the 2% and put it on the top and 100 on the bottom.
Okay, indeed, that's the second step. Third step, something comes after the word of.
It'd be the y.
The y of what? Last step, something I haven't used yet. That's my 5. Then that nice shortcut, I can multiply the two numbers that are diagonally opposite each other. I can divide by the lonesome one that's opposite the y. In general, the proportion method takes a little bit more writing than the translate method. And it wasn't too hard to fit 3 of them on the slide and have some room left over, whereas here I had trouble just fitting 2 of them. So there is a little bit more writing, but if you like cross multiplying, here you go, cross multiply. Okay, we're pretty much done. So looking at this, then there are some patterns, like what is y% of z? Does the what come first or second or third? But don't pay attention to the patterns. That's going to make it too hard for you. Just use the nice processes that always work. But the patterns are important because the way English is flexible, I can always rewrite things to have the what comes first and the is comes second and the of comes third. If somebody gives me a different way of asking it, I can rephrase it in that order. So here's like the awkward English. Here's the smoother sounding English. Right? Slightly more awkward, slightly more smooth, which means when we write our own, it can look like Mad Libs. Blank is blank percent of blank. So this is your sort of concluding thing to go in your head. You will see this more when we meet again. But when I'm writing percent sentences, then I have the power to always do it in this order. A blank, some part or change or new amount, is what percent, right, out of 100 of this whole or original or baseline pie that I'm talking about. Okay, see if you get it. Actually, that's going to be too wide. So in this case, blank is blank percent of blank. A young couple earns money by improving a fixer-upper home. They buy the home for $65,000, and after months of repairs and improvements, they sell it for $105,000. A friend asked them what percent increase in home value they created. So which numbers or word what goes in which of my Mad Libs blanks? Which is my whole or original or baseline?
Uh, 60,
65.
65,000.
Yeah. That's the number I'm comparing others to. What goes in the percent spot? I don't know. There's no percents. So that's my what? And then the other number, this is my change, my new amount. In this case, it's a new amount. And if I solved this using either method I just did, I would get something a little bigger than 100%. I would get, what is it, 105 divided by 60. I would get about 162%. So percents can be bigger than 100%. Right? They didn't quite double the value of the home. It wouldn't be 200%, but it's bigger than 100%. Right? They've made almost 40,000 homes. So this Mad Libs thinking, don't get fooled by the picture. It's not true that the part, the new, is always smaller than the baseline or the whole. In this case, the new amount is bigger because their house went up in value. Yay. So don't trust the picture too much. But this Mad Libs thing of blank is blank percent of blank, we can always use. And with that, we're out of time. You have finished mortgages. You can start your mortgage homework if you haven't yet. We've barely started a savings for retirement. I would just ignore that till Thursday, unless you want to do some percent sentence practice. Thank you for paying attention in class. Have a good couple days. If you didn't get back
Thank
to
you,
me
David.
on what two big issues you want to work on, which I think was only Timothy, then think about that and let me know that in email or something.
All right, thank you.
You're welcome. We do have a study session this afternoon if anyone wants to do that, or we could just let the Math 20 people claim it. But if you want it, be here.
Perfect, thank you.